Close and secure the forward bunker door.
Instrument room stray voltage checks are complete.
Roger. Instrument room, have the arming crew inspect the instrument room fire control safety jumper.
The instrument room fire control safety jumper is acceptable for use.
Roger. T-minus 15 minutes. Instrument room, have the arming crew install the instrument room fire control safety jumper.
Installing the instrument room fire control safety jumper. Instrument room fire control safety jumper is installed.
The primary and secondary instrument room safety jumper indicates show in. Instrument room, have the arming crew install the instrument room fire line key and rotate to the closed position.
The fire line key is installed and rotated to the closed position.
The primary and secondary T97 key switch indicates show closed.
Arming preparations are complete.
Evacuate to T22.
Evacuating the instrument room.
Seven, 6, 5, 4-stage engine start. 3, 2, 1.
Hi everyone, I'm Megan Carter, Media Specialist for NASA's Space Launch System rocket. As teams at NASA's Kennedy Space Center in Florida are busy getting ready for the first crewed Artemis mission, work continues all over the United States to prepare for future missions as well. One of those locations is right here in beautiful Promontory, Utah, at the Northrop Grumman facility, where I'm coming to you live today. Our partners here at Northrop Grumman have been working to develop a more efficient, lower-cost commercial solution for the boosters for the Space Launch System. As you can see, it is a beautiful day here in Utah, and we are actually just a few minutes away from a hot fire for the demonstration MOTOR-1 test. The booster motor for today's hot fire is actually locked up on that hill in the test stand right behind me, and it's just about ready to be fired up. The boosters for NASA's moon rocket are the largest, most powerful that have ever been built for flight. And there are 2 boosters that flank either side of the rocket and together produce millions of pounds of thrust at launch. Today, we will get to witness the power of just one of those boosters. But before we kick this off, we're actually going to turn it over to Alyssa Lee in Huntsville, Alabama at Marshall Space Flight Center to learn a little bit more about what we're going to be seeing today.
I am very excited to be here at NASA's Marshall Space Flight Center with a resident SLS and booster expert. Joining me today is Julia Codobande, the Deputy Manager for the SLS Booster Element Office. Thank you so much for joining me, Julia. We are less than a year away from the launch of Artemis II, which will see SLS and NASA's Orion spacecraft on the first crewed mission for the Artemis campaign. So, would you be able to give us a little quick update on the progress for Artemis II?
Yeah, so Artemis II is currently being stacked at the Vehicle Assembly Building at Kennedy Space Center in Florida. So the twin solid rocket boosters have already been stacked, and the core stage with its 4 RS-25 engines has also been mated to the boosters. We have the Orion stage adapter here at Marshall Space Flight Center ready to ship and be integrated with the vehicle as well. Orion is currently being processed at KSC in the multi-payload processing facility. It's getting its propellants, its consumables, and the launch abort system, and once that's complete, it'll be ready to be delivered to the Vehicle Assembly Building to be stacked onto the SLS rocket as well.
Wow, that's so exciting. It's going to be here before we know it. So as your role as the Deputy Manager for the Booster Office here, what does your job entail? And with that, what are you most looking forward to out of today's test?
So yeah, as Deputy Booster Manager in the Booster Element Office, we are part of the SLS Program Office, and my responsibility is to advise and to assist the Booster Manager in things like programmatic and fiscal and technical planning, procurements, contract actions, DD&T&E, design development, test and evaluation, as well as production and operations of the booster. And this is going to include all of the support equipment as well as the facilities that are needed. What I'm most looking forward to today kind of goes a little bit back into history. When we started the SLS program, in order to save cost and schedule, we implemented the shuttle's proven heritage hardware into our design. But this is being depleted as the Artemis program progresses, and it's just not practical to restart the manufacturing from that 1970s era. So for the last several years, we've been developing what we call the Booster Obsolescence and Life Extension, or BOLE. And so the BOLE is actually implementing new manufacturing processes and new materials from domestic sources. And so this test today is going to be the first full duration, full-scale test of the BOLE motor, which we're calling DM1, or Demonstration Motor 1.
So how does that tie into the goals and objectives of the test today?
So our goals today are to take a look at the performance of the BOLE motor. We are going to be looking at things like the ballistics performance, so the pressure and the thrust versus time, the burn rate of the motor, the pressure drop, the ignition characteristics. We're going to be taking a look at the performance of the internal insulation of the motor, in the case acreage and dome areas. We also have a new carbon fiber composite case, which will be taking a look at its performance during the test, as well as the joints and the seals. We'll be taking a look at our nozzle ablative performance and the electronic thrust vector controls vectoring of that nozzle. And one of the other things that we're demonstrating with the BOLE DM1 today is that we're able to produce that next generation motor that is high performing, addresses our obsolescence issues, and does it more efficiently and at a reduced cost, which we are realizing a 25% reduction in cost. But going forward, any SLS booster or commercial solid rocket booster is going to need this next generation design because of the obsolescence issues.
Great, thank you, Julia. That was very enlightening, and I am so pumped to see this thing fire. Speaking of, I think it's time we check back with Megan in Utah to see if we are getting close to this big event.
Thanks, Alyssa. We are now less than 5 minutes away from the hot fire. We're going to take a quick break, and I'm going to get into position to watch. When we come back after the test, we'll actually be answering a few of your questions that were submitted in the chat. But for now, let's get ready to fire this booster up. Just before the test, you are going to hear a countdown from the test conductor, followed by the 2-minute booster firing. Enjoy. We'll see you back here shortly.
This is the test conductor. Report system status.
Support systems are go for static test.
Low-speed systems are go.
High-speed systems are go. Ultrasonic data systems are go.
TVC systems are go.
High-speed video systems are go. Motor temperatures are go. We are go for Bolay DM1 static test.
T-minus 3 minutes. Low-speed data operators, begin recording. High-speed data operators, at T-minus 70 seconds, begin recording and report at that time.
Roger.
All low-speed data systems are recording.
Roger. T-minus 2 minutes. T-minus 90 seconds. T-minus 80 seconds.
Test control coordinator, stand by to commit the motor.
Standing by. T-minus 70 seconds.
Commit the motor.
The motor is committed. T-minus 60 seconds.
All high-speed systems are recording.
Roger.
Ultrasonic data system is recording.
Roger. T-minus 50 seconds.
TVC is go for static test.
Roger. T-minus 40 seconds. T-minus 30 seconds. T-minus 20 seconds. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire. T plus 5 seconds. T plus 10 seconds. T plus 20 seconds. T plus 30 seconds. T plus 40 seconds. T plus 50 seconds. T plus 60 seconds. T plus 70 seconds. T plus 80 seconds.
Central Support System Operator, enable the deluge, CO2, and quench tool controls.
Enabled.
T plus 90 seconds.
Open the accumulator enable valve.
Accumulators enabled.
T plus 100 seconds.
Activate aft deluge.
Activated.
Whoa.
T plus 110 seconds.
Activate forward deluge.
Activated.
T plus 120 seconds.
Activate head end CO2.
Activated.
Activate quench tool forward command forward. Activate aft CO2.
Activated.
TVC power is disabled.
Roger. T plus 160 seconds. T plus 170 seconds. High-speed data operators, stand by. High-speed data operators, stop recording.